Jamb must repeat question 5. I swear to God, this question is easy and you must see it in your Jamb UTME 2026. If you are a Jamb UTME student offering chemistry and you skip this question, your village people go gum have that number for your head during your UTME exam 2026. So listen, pay attention, lend me your ears, take your pen and your paper to jot down anything you hear from this lecture, because that's what you are going to use for subsequent revision. When it's 3 weeks to your Jamb UTME, that's how we prepare for Jamb UTME. I know the stress students. I don't believe in stressing someone. I don't stress anybody. I believe in doing things through the easiest routes, through the easiest way, passing through the easiest way, because there are different ways to do something. So you either choose, you are at that point of making the decision to choose the path that you are going to follow. Are you going to follow the easy path or you are going to follow the difficult path? The easy path is my student don't open textbook. No need to open textbook. You take all my lectures, my short lectures, my Jamb must repeat questions, revise all the notes you've made from the lectures, study your past questions and answer. You are ready to bulldoze Jamb. 300 points in Jamb UTME 2026 is nothing. It's nothing. Because when you enter the exam hall, see how you the answer question. Number 2, B. Number 3, C. Number 4, A. Number 5, D. Number 6, B. Enough. Let's look at the question we have here. The question reads, Burette test is a chemical test used for detecting the presence of what? The option here reads A. Carbohydrates, B. Proteins, C. Amines, D. Alkaloids. Jamb 2026 candidates, what's your answer? Let's find out. I am going to use this opportunity to teach you all the tests, especially in organic chemistry, and what they are used for, what they are used to test. I will teach you the name of the test and what they are used for. Everything that you need to know inside your Ababio textbook. We don't bomb everything with inside there. Everything they here. Let's go. Take your pen and your paper. Jot down everything you hear. Let's go. Element analysis. Okay. Element analysis, also called the what? The Larsen test. The Larsen tests. Those are analysis for element or the presence of elements. The first one we have here is test for carbon and hydrogen. The test for carbon and hydrogen. That's the name. And the test used to test for carbon and hydrogen is the bond sample. Okay. And after you use the bond sample test, what confirms the presence of hydrocarbon or hydrogen and carbon? It's a smoky flame. It burns with a smoky flame, or heats with what? You heat the solution with what? Copper oxide. So when you heat the solution with copper oxide, what is the observation? It turns slime water making. So carbon 4 oxide is formed, or carbon 4 oxide is liberated, and water is also liberated, which turns blue cobalt chloride paper to what? Pink. So when blue cobalt chloride paper turns to pink after the solution is heated with copper oxide, the test is usually the test for hydrogen and carbon, or carbon and hydrogen, or the test for hydrocarbon. Number 2 is test for nitrogen. The Larsen extract is added to iron 2 tetrasulfate 6 and it is heated. After heating it, you acidify with hydrogen tetrasulfate 6 acid. And what do you get on observation? On observation, you get a Prussian blue color, which indicates or confirms the presence of nitrogen. The third we have here is test for sulfur. And the test for sulfur, you bring the extract that you are suspecting that there's sulfur inside. You add it with sodium nitroprusside. And what do you get? You get a purple precipitate. That confirms the presence of sulfur. Or you can also use the sulfur extract. You add lead 2 acetate to the sulfur extract, or the extract in question that you are suspecting that there is sulfur in it, or you want to test, the extract that you want to test. When you add lead 2 acetate to the extract or the substance, you observe a black precipitate of lead sulfide. That confirms the presence of sulfur. Okay. Number 4 here is test for halogens. Okay. What are the halogens? Halogens such as chlorine, bromine, and iodine, and so on and so forth. So you get the extract, that's the substance in question. You are trying to test for halogens. Okay. When you bring the substance, you acidify the substance with hydrogen triazonitrate 5 and you add silver triazonitrate 5 to the solution. And what do you observe? What is the observation after adding these two? The first observation is a white precipitate soluble in ammonia. That indicates or confirms the presence of chlorine ion. For chlorine, you are going to get a white precipitate which is soluble in ammonia. Then for bromine ion, you are going to get a cream precipitate partially soluble in the same ammonia. Then for iodine ion, you are going to get a yellow precipitate which is insoluble in the same ammonia. So for chlorine, white precipitate. For bromine, cream precipitate. For iodine, yellow precipitate. So we are done with the Larsen test. Let's look at the physical test. The first we have here is number 5, ignition test. And in the ignition test, what do you observe? You observe a smoky flame. Okay, when you get a smoky flame from the ignition test, that shows that you have an aromatic compound or unsaturated hydrocarbon. Okay, an aromatic compound such as benzene, okay, or toluene, okay, or an unsaturated hydrocarbon such as ethane. And when the test, the ignition test is non-smoky, okay, it's non-smoky, that indicates the presence of alkane. And let me explain to you why these aromatic hydrocarbon and unsaturated hydrocarbons are both smoky. Why it appeared smoky is because of the high percentage of carbon. You know, the unsaturated hydrocarbon has a higher percentage of carbon, you know. So, you know, the unsaturated hydrocarbon has 2 carbon bonds. They have more than 1 carbon bonds, either 2 or triple carbon bonds. So, to break that bond is going to require a lot of smoke, high concentration of carbons in it, okay? The bond is very strong, okay? Double carbon bond and triple carbon bond. That's why you're having this smoky flame. Unlike the alkanes that have just 1 carbon to carbon bond or single carbon to carbon bond, okay? So, number 6 here is the solubility test. And the first one we are doing here is solubility in water. Okay, solubility in water, dilute sodium hydroxide, dilute sodium chloride, dilute hydrogen chloride, concentrated tetrasulfate 6 acid. What is it used for? It is used to classify acid, base, phenol, amino compounds, and so on and so forth. Let's look at the test for hydrocarbons. And the test for hydrocarbons, the first we have here is number 7. The test for alkenes, which is the double carbon to carbon bond, or the hydrocarbon with double carbon to carbon bond. And the first test we have here is the bromine water test, okay? Alkenes, this decolorizes bromine water, okay? The second test we have here is when you acidify the solution with acidified potassium tetraoxomanganate 7. It's also called the Bayer's test, okay? It's also called the Bayer's test, okay? So what happens? The potassium tetraoxomanganate 7 turns from purple to colorless, showing that the alkanes has been oxidized, showing that alkane was oxidized. The next one we have here is number 8, the test for alkyne, which is the terminal test. It's usually done with ammonica, okay, which is copper chloride, okay. So, and you can also do this same terminal test, that's the test for alkyne, with ammonica silver triazonitrate 5, which is going to give you a white precipitate. The white precipitate confirms the presence of alkyne. The next here we have here is number 9, the test for aromatic hydrocarbons. And the test for this aromatic hydrocarbon, we usually use the bond test, very smoky flame, just like we explained before. And we can also use the nitration test, a test whereby concentrated triazonitrate 5 acid is acidified with tetraoxosulfate 6 acid. It gives us a nitro derivative, which is yellow and oily. So it's yellow and oily. That's what confirms the nitration test, that an aromatic compound is present in the substance. Test for alcohol. Test for alcohol. The first we have here is number 10, sodium metal test, okay? What happens? Effervescence test, okay? Hydrogen gas shows that it indicates that alcohol is present. Effervescence occurs, okay? So hydrogen gas is going to be liberated, yeah? And that shows that alcohol is present. And what is effervescent? Effervescent is when a substance suddenly turns from liquid to gas, okay? It usually happens when the substance is exposed to the environment or to the atmosphere. It turns from liquid to gas very fast. It's very, very common among alcohols, or among the all functional group in organic chemistry, like propanol, ethanol, methanol, and so on and so forth. Number 11, the 11th one we have here is the next one we have here is number 11, Lucas test. Tertiary alcohol. It turns, when there is a tertiary alcohol present, it turns cloudy immediately. Okay, a tertiary alcohol. You know what a tertiary alcohol is now, like the alkanoids. Those are tertiary. Then the secondary alkanol, okay, the secondary alkanol is going to turn cloudy in 5 minutes. So the time is going to determine whether it's tertiary. So the tertiary is the highest, which occurs immediately, cloudy immediately. Then the secondary, within 5 minutes, it turns cloudy, the Lucas test, okay. Then if a primary alcohol is present, such as the ethanol, okay, it remains clear. The next we have here is number 12, chromic acid test. And for primary and secondary alcohol, when you use the chromic acid test to test for primary and secondary alcohol, or to test for alcohol, when is primary or secondary alcohol present, it turns this chromic acid from orange to green. But when the tertiary alcohol is present, there is no change. The next we have here is test for phenols. Number 13 is the ferric chloride test. And the ferric chloride test, violet, blue, green color, that indicates the presence of phenol. When you add the ferric chloride to the solution and it turns violet or blue or green, that indicates, or it confirms, the presence of phenol. Number 14 is the bromine water test. And the bromine water, decolorization plus white precipitate. So decolorization of the solution, when you add bromine water to a solution that you are suspecting that phenol is present, or you want to know if phenol is present, on adding bromine water to the solution, it decolorizes the solution and forms a white precipitate. That indicates or confirms the presence of 2,4,6-tribromophenol. The next we have here is 15, the litmus test. The litmus test is used to also confirm the presence or absence of phenol. Okay, phenol turns blue litmus paper red, weak acidic. So phenol is a weak acid. It turns blue litmus paper red. So you are going to notice that the red is going to be a fading one or a faded red. The next we have here is carboxylic compounds. Okay, number 16 is the first we have, and we are testing for carboxylic compound. We use 2,4-DNPH test, or it can be called the Brady's test. You can use it to test for carboxylic compound. What do you get? When you see an orange or yellow precipitate, it indicates that aldehydes/ketones is present, which are all, both of them are carboxylic compound. Okay, aldehyde or urea, they are all carboxylic compound, or ketone, they are all carboxylic compound. The next test you can also use to test for carboxylic compound is the Tollens test. Okay, the Tollens test, when you add aldehyde to the Tollens test, or aldehyde is a carboxylic compound. When you add aldehyde to it, what do you get? You get a silver mirror. You get a silver mirror looking at you. You see yourself reflect in the silver mirror. So that is the Tollens test. So when you see silver mirror, the Tollens test is used to test or ascertain the presence or absence of aldehyde. This one is peculiar to aldehyde. Okay, so the next we have here is number 18. The next test used for carboxylic compound is the Fehlings/Benedict test. To use it to test for aldehyde, when you add Fehlings or Benedict test, or Benedict or Fehlings solution to the solution in question, you are going to get a brick red precipitate, which indicates the presence of aldehyde and copper-2 oxide. The next we have here is the Schiff's test. The Schiff's test is also used basically for only aldehyde. Okay, aldehyde is a carboxylic compound. It's used basically for aldehyde. And what happens when you add the Schiff's reagent to this solution in question that you are suspecting that it might contain aldehyde? It turns pink or magenta. Okay, it turns the solution pink or magenta. This coloration indicates the presence of aldehyde. The next we have here is number 20, the iodoform test. A yellow precipitate, where you add the iodo reagent, okay, to the solution in question that you are suspecting that you have a carboxylic compound present in it. When you get a yellow precipitate, that shows that methyl ketone or ethanol is present in the solution. That confirms the presence of methyl ketone or ethanol. Test for carboxylic acid. The first test we have here for carboxylic acid is sodium hydrogen carbonate test. Sodium hydrogen carbonate test. What happens? Effervescence occurs. Okay, effervescence occurs, and it occurs due to the presence of carboxylic acid because carbon-2 oxide is released. You know what effervescence is? When liquid suddenly and rapidly turns to gas when exposed to the atmosphere. The next we have here is the litmus test, and it turns carboxylic compound turns blue litmus paper to red, showing you that it's a weak acidic compound, such as carboxylic acid, such as ethanoic acid, can turn blue litmus paper to light red. The next we have here is 23, esterification test. And what happens? Warm the ester or warm the solution in question with alcohol plus acid. What do you get? You get fruity smell. So when you warm the solution with alcohol and acid, you get what? Fruity smell. That tells you that there is an ester present in such solution. Test for esters. Number 24. The first test for ester we have here is hydrolysis, which is acid/base hydrolysis. You hydrolyze acid and base, and it gives you what? Alcohol plus mineral acid. Detect the smell/pH. Check for the smell. Does it have a sweet smell? If it gives you a sweet smell, just know that ester is present. Hydrolysis test is used to test for ester. And the next one we have here is number 25, which is warm with hydroxylamine. Warm the solution in question with hydroxylamine. And what confirms the presence of ester? Hydroxylamic acid test. You warm it with hydroxylamic acid, okay? And a deep red with iron 3 ion confirms the presence of ester in hydroxylamine test. The next we have here is test for amines. And under the test for amines, the one we have here first is 26. Litmus test is used for the test for amines. And amines are basic. They are basic. They are bases. You understand? They are bases. So they turn blue litmus and stay blue. So when you use a blue litmus paper on them, the blue litmus paper continues to stay bluish. Okay. So a red litmus paper turns to blue. That tells you that amines are basic, or they possess the qualities or the properties of bases. The next we have here is number 27, which is the reaction with diazonitrate 3 acid. Okay. The primary aliphatic gives a brisk effervescence of nitrogen gas. The primary aromatic gives a diazonium salt stable in cold but unstable in heat or hot environment. The third we have here is secondary aromatic. It gives us what? Nitrosamide, a yellow oily substance. Okay. Then the tertiary aromatic, it gives us no visible reaction. The next we have here is 28, carboxylamine test. Okay, the carboxylamine test is used for only primary amines. And what is the observation? The observation is that offensive smell of isocyanide is observed. An offensive smell of isocyanide is observed. The next we have here is the test for amide. We just finished treating amine. Now we are treating amide. Now the first we have here is number 25, and the test is heating with sodium hydroxide, which is caustic soda. What happens? What is the observation? It liberates ammonia. It turns red litmus paper to blue. It turns red litmus paper to blue. That's telling you that it is basic. The next we have here is 30. Reaction with hypochlorites. Hypochlorites. Sodium hypochlorites. Carried out under the Hofmann's degradation. Here is test for carbohydrates. We have the number 31 here. Molish test is the first test for carbohydrates. You get a purple ring which indicates the presence of carbohydrates. A purple ring appearance of the precipitate indicates or confirms the presence of carbohydrate. Then number 32 we have here is Benedict/Fehling test. Okay, brick red precipitate confirms the presence of reducing sugar. Jamb and WAEC loves this Benedict and Fehling test so much. The next we have here, still under the test for carbohydrates, is Baffo test. Okay, the Baffo test uses you add monosaccharide to the carbohydrate or the solution that you are suspecting that you have carbohydrates, or you want to know the percentage of carbohydrate in the solution. You add monosaccharide to it, and what do you get? You get a red precipitate quickly. You get a red precipitate quickly. That's what you get. You can also use the iodine test for testing the presence of carbohydrates. Okay, the iodine test, you usually get a blue-black. Okay, a blue-black. This one is very common in biology. We use it to test for the presence of starch in leaf. Okay, so when you get a blue-black coloration, that indicates the presence of starch, a polysaccharide. But when you get a reddish-brown coloration, that indicates the presence of glycogen. The next test we have here is test for proteins. Okay, for the test for proteins, we use the Burette test, and on observation, the violet color of the solution gives us the indication that protein/peptide bond is present. So when the solution turns violet, when you add it to the suspected solution, that confirms the presence of protein or peptide bond. The next we have here is the xanthoproteic test. The xanthoproteic test, it turns yellow. Okay, it turns orange with alkali, aromatic, amino acid. The next we have here is the milling test, and this milling test, Jamb also loves setting this question. Okay, question from this milling test. What happens when you add the milling reagent to the solution in question that you are trying to test if protein is present in it? The solution turns red color when there is presence of phenolic amino acid or tyrosine. Okay, this tyrosine is one of the essential amino acid in the human body. So the next we have here is number 38, nihydrin test. So this nihydrin test, when you add the nihydrin reagent to the solution in question, you are going to get purple or blue coloration, which indicates the presence of free amino acids. Test for fat and oil. Under the test for fat and oil, this is very easy. Number 39, the translucent spot test, leaving translucent stain on paper. When you use the translucent spot test, it's going to leave a translucent stain on the paper. That indicates the presence of fat and oil. The number 40 is the next we have here, still under the test of fat and oil, emulsion test. Okay, white emulsion with water plus ethanol. It shows a lipid that is present. So when you have a white emulsion with water or ethanol, okay, you add water and ethanol to the system and you get a white emulsion. That indicates the presence of lipid. The next test we have here is Sudan 3 and Sudan 4 tests. Jamb also likes setting this questions from Sudan tests. Sudan 3 and Sudan 4, they love setting questions from this place. When we get a red coloration, that indicates that fat and oil are present in the solution. So number 42, acrolein test. So this acrolein test, when you heat this glycerol-based fat heat, you heat it with the acrolein reagent. Okay, this is the acrolein reagent. You heat it with the solution in question. So when you heat it with the solution in question, you get a pungent smell of an acrolein. Unsaturated test, unsaturation test. Okay, on the left hand side of the table we have number 43, bromine water. Decolorization of bromine water indicates the presence of unsaturated hydrocarbon. Then number 44, yes, still on the left hand side of the table, we have potassium tetraoxomanganate 7, which is the Bayer's test. We have done this before. So when you get a purple precipitate that later turns to colorless with brown precipitate, just know that unsaturated hydrocarbons such as ethene or ethane is present. On the right hand side of the table we have number 45 there, and that's the test for aldoses and ketoses. And this test for aldoses and ketoses, we usually use the Sally-Wanoff test for advanced organic chemistry. For the aldoses, you are going to get a slow pink changes in color. Okay, you are going to get a slow pink coloration, while for the ketoses you are going to get a rapid red coloration using the Sally-Wanoff test or the Sally-Wanoff reagent. With this we have come to the end of the lecture. So now let's go back to our Jamb must repeat question 5 and Jamb must repeat question 6. Back to the question. Jamb must repeat question 5. The question reads, the Burette test is a chemical test used for detecting the presence of what? A. Carbohydrates. That's obviously not the answer. D. Alkaloids. This is obviously not the answer. C. Amines. This is obviously not the answer. Or for your correct option, option B, protein. So the Burette test is used to indicate the presence or confirm the presence of protein. Thank you so much for taking this lecture. Please do well to follow me across all social media platforms at Nkwado Augustine. Hope you enjoyed the lecture and hope you made notes. Do you have any questions? Drop your questions in the comment section, and as soon as I see your question, I am going to do justice to your question. At this moment in time, I'm out. I wish you success in your Jamb UTME 2026. All UTME candidate 2026. Peace out.